In this section, I'll be talking about the science behind the Three Sisters. As an agronomic scientist, I think I can bring you a particular perspective on the Three Sisters cropping system. I'd like to start out with one of the myths that many of us have about it. Many people believe that indigenous agricultural systems, almost by definition, are going to be primitive, backward, and unproductive. But after several decades of research, what we actually know now is that indigenous agricultural systems are actually very agronomically productive. They often reflect a very sophisticated knowledge of crop soils and the environment. So let's look a little bit more carefully at the Three Sisters Hill system, starting first with the hills. As you see in the photo here, this was taken in the early 1900s. It was known to be an old Indian planting field in western Massachusetts. What's striking about it are the very large mounds that are fairly regularly placed throughout the field. As an agronomist, one of the first questions that I have is, well, why would anyone go to all the trouble to plant on those mounds? Why not just plant on the flat soil? Well, it turns out that particularly in the Northeast and in New York State, planting on mounds makes a lot of sense. Let's talk about a few of the advantages that a hill system or a mound system offers. First, the hills help control plant population. Corn is very different from other small grains like rye, wheat, oat, and also barley, in that it's very sensitive to the population at which it's planted. It needs to be planted in a very uniform spacing. Small grains like wheat, oats, and barley, on the other hand, don't really require that. With the hill system, what this does is it allows farmers to establish a plant population, to maintain it over a period of time, and simply by changing the number of kernels per hill, you can either raise or lower that plant population. It's really a very elegant solution to a very significant agronomic problem. Another advantage of the hill is that it offers a way to improve the soil physical environment. Soils in the Northeast are very subject to being wet and cold in the spring. The hill is a means of both warming the soils early and also allowing them to dry out. The mounds, with their increased surface area, take the sun's rays early in the spring, and they warm up more rapidly. Also, that increased depth that the mound provides allows water to drain out more quickly. So the end result is that in the springtime we have soils that are warmer and drier. Corn is a plant that really hates to have its feet wet. So being able to plant on a hill in the Northeast makes a lot of sense. From an agronomic perspective, we can perfectly understand why native peoples would have chosen to plant corn in hills. Another way that the hills allow for an improved soil physical environment is that the residue from the corn plant and the weeds were all returned right back to that mound. In this way, organic matter is being added to the mound, and when organic matter is added, it increases both soil aeration and water movement. So these are, again, two very important physical aspects that are enhanced by using mounds. Another way that the mounds are important is they allow us to reduce soil erosion. Sometime in the 1950s, U.S. soil and crop scientists realized that one of the critical constraints to U.S. agricultural production was soil erosion. In other words, the loss of soil primarily through rainfall. One of the things that they did was to begin to develop technology and to develop educational programs to persuade farmers to stop plowing. In other words, it's tillage. When we invert the soil at the beginning of the season, we remove all of the vegetation until the crop is planted and grows up and gets its own canopy going. That field is very, very vulnerable to loss from any rainfall event. The solution that soil and crop scientists have come up with in the United States is to persuade farmers to reduce the amount of tillage that they do. In other words, to keep the ground covered for as long as possible. Well, U.S. scientists were convinced that they had developed this technology, which today we call conservation tillage or no-till agriculture. But in reality, native farmers in the entire Western Hemisphere have been using no-till agriculture for a couple thousand years. Certainly Iroquois farmers used the no-till system to provide protection to the soil in the same way that farmers today use no-till agriculture. Another advantage of the hill system is that it allows the concentration and the recycling of plant nutrients. Now you can imagine that Iroquois farmers back in the 15, 16, and 1700s couldn't go down to their local Agway store to buy inorganic fertilizers. Rather, they had to rely on the natural decomposition products that are released when plant residues decompose. The hill system allows for those residues to all be concentrated right in the area where the corn is actually going to be growing. So the corn roots then have access to the decomposition products of those plant residues exactly when they're going to be needing them and in the area where they're going to be needing them. It's a very nice system that allows for the recycling of nutrients and allows for a productive agricultural system when there's no access to synthetic fertilizers. The final aspect of the hill system is that it helps facilitate weed control. Remember that I talked about in earlier sections that Iroquois people were planting very large expanses of corn. We're talking about fields with sometimes 50, 60 acres of corn. Imagine the problems of trying to control weeds in a cornfield of that size. By planting in hills, what it does is it allows the farmers to concentrate their weed control efforts on the area right around those hills. In other words, they hoe out the weeds that are growing right in the hill, and they ignore the rest that are growing between hills. So this is another aspect that was very important. Now switching from the hills to talking about the plants, the Three Sisters are what today we would call a polyculture. Agronomic scientists know that polycultures offer a lot of advantages to farmers. Basically, there are three advantages. First, the polyculture systems, because they're composed of multiple plant species, mimic natural plant communities. And in this way, it makes them less vulnerable to catastrophic damage from either weather, insect, or diseases. The second advantage is that we know that we get increased agricultural productivity through the more efficient use of nutrients, water, and light. In other words, when we have different plants growing, they're able to exploit different parts of the environment. Tall plants pick up the sunlight up high, lower plants grab the sunlight that wasn't intercepted higher up. The root systems are different, and often even the times of growth are different. So they're able to make more efficient use and thus increase agricultural productivity. The third important advantage of polycultures is that they frequently include a legume, something like a bean or a pea. Legumes are very, very important in polycultures because they add what we call free nitrogen. They have the capacity to take atmospheric nitrogen, and through a symbiotic relationship with bacteria on the roots of the legume, they're able to change atmospheric nitrogen into a form of nitrogen that plants can use. Legumes are about the only plant group that can do this, and other crops like the grasses, corn, and other broadleaf crops like squashes can't do it. So when you have a legume in your cropping system, in your polyculture, it's a very, very important component because it's adding nitrogen, which is critically the limiting plant nutrient for crop growth. In terms of intercropping with the Three Sisters, the three different plants play very critical roles and also very different roles. Iroquois people talk very fondly about the Three Sisters. In fact, we call them Junhequa, our sustainers. We often visualize them as people with very different characteristics and personalities. You can think of the corn as being our eldest sister, and she stands very tall and straight. She's got her hat on up above, and she's got her face is the corn ear itself. She's very serious, she's very important, and she's very responsible. The second sister is Beans, and Beans completely different. She's pretty shy. She twines around the legs of her elder sister, kind of peeking out from behind. She's kind of joyful, but just a bit shy. The third sister, Squash, is completely different. She's a little one. She grows close to the ground. She's kind of wild and impish. She's the one that's kind of getting all over the place. If there's a troublesome member of your family, the little kid that's always getting in trouble, you can think about Squash. That's the role that she plays in the Three Sisters. Of course, agronomic scientists have a very different version of what the three crops do and how they're different. We know that they differ first in their botanical classification, second in their growth habit, third in their agronomic function, and fourth in their food value. I like to think that every crop from an agronomic perspective has its own purpose. And I always start with corn, the eldest sister. Corn is the kind of engine of the Three Sisters cropping system. It produces the largest amount of calories. It's the crop that is of most importance. But not only does it produce calories, a tremendous amount of energy, but corn also has a significant protein content. Typically, 7 to 10% of the grain will be protein, and of course very important to people's diets. Corn is also an amazingly productive and competitive crop. It competes very well against both weeds, and it's very resistant to insects. Certainly for an indigenous cropping system, corn is a fantastic performer. And finally, corn provides the support for the twining beans. Beans, as I mentioned before, are critically important because they provide nitrogen to the crop system. In most cases, nitrogen will be the limiting element for cropping systems. Beans are also important because they produce large amounts of protein. In fact, the amino acids in beans complement those in corn so that the two crops, when eaten together, provide a very complete and high quality protein. Now pumpkins, which you see here running all around, the final sister, the one that I mentioned is so wild and more or less out of control, pumpkins also provide a number of very important parts to this cropping system. Surprisingly, the pumpkin flesh gives a significant amount of calories, but it also provides nutritionally valuable vitamins and minerals that would otherwise be lacking. The seeds of pumpkin are also very high in oil and protein. And finally, their very low and aggressive growth habit suppresses weeds and captures resources that would not be used by either beans or corn. As an agronomic scientist, I can recognize that managing polycultures is a surprisingly complex activity. In many ways, it requires a lot more knowledge than it does to manage monocultures of crops. First, you have to have in-depth knowledge of each one of the crops, of the squash, the beans, and the corn. You have to know how to grow each one of those crops well. But second, it requires an understanding of the dynamic interactions between the crops. How is the presence of the beans going to influence the corn? What impact will the squash have on both the beans and the corns? And third, it requires the ability to predict these interactions over a wide range of environmental conditions. You need to be able to know what the effects of planting date, precipitation, insect attacks, all of these, how they're going to affect each one of the plants and the interactions. Of course, all of the polycultures, when farmers grow them, they need to absolutely guarantee that their primary crop, in this case with the Three Sisters, is corn, is never compromised. Recently, as scientists have recognized that indigenous agricultural systems like the Three Sisters represent very complex knowledge systems, they've begun to look at them in a new light and with much greater respect. In fact, many scientists, myself included, are beginning to see that the Three Sisters, as an indigenous cropping system, has a lot to offer in terms of thinking about the problems that contemporary farmers face today in developing a sustainable agricultural system. So I hope you'll join me in the next section as we talk about the connections and the contributions that the Three Sisters might make to this discussion.